Okay, so today we start chapter uh, 7, systems of first order equations. First order linear systems or equations. Okay, so we mean by a system? Here we have uh, we are again dealing with ordinary differential equations, but since it's a system, we have more than one unknown function. So t is again independent variable, and y1t, let's say y and t, dependent variables, and we have equations, differential equations involving this yi's. For example, let me write down. Uh, okay, so let's say y1 double prime plus t times y2 double prime minus 3 uh, cosine t y1 prime plus 5 y2 prime equals or uh, minus 7 y1 plus 2y2 equals, let's say, e to the power t times cosine 2t. This is one equation. It's a linear equation, and it's second order. Another one, let's say, 3y1 double prime minus 5y2 prime, y2 double prime plus e to the power t y1 prime plus cosine t y2 prime plus, let's say, 5e1 and plus, let's say, 3y2 equals 0. So this is a system of two equations. What is the order of this equation? The highest order derivative terms are double primes, right? Second derivatives. So this is a second order linear equation. It is linear because no two y terms are in product form, right? Uh, in each term, we have a single y term, and the coefficient of y is a function of t. Okay, so this is a linear second order uh, system of ordinary differential equations. Okay. Well, in this chapter, we will consider first order equations. It means we will have only first derivatives, not second derivatives. So in this chapter, we will consider only first order uh, systems of equations. So we will have only first order derivative terms. The general form of such a system is as follows. So I have only first derivatives. Let's say again the same setup. T is the independent, y1 up to yn are the dependent variables. Then we will have something like this. Let's say a11 times y1 prime plus a12 y2 prime, and then here of course these are functions of t, a1 and yn prime, and then we have uh, uh, b terms. Well, actually, let me write not like this. Okay, let's say yeah, uh, okay, we will have something like this: a y prime plus by, or maybe I should write like this, plus c, where y is this y1 yn, y prime is of course just the derivative terms, and abc are uh, matrices of functions of t. So for example, A is something like this. It's an n by n matrix, Aij T. So this is n by n. B is an n by n matrix because they are multiplied with y1 up to yn, and C is a column matrix. So this is just CIT. This is just n by 1 matrix. Let me make an example. So we will have, for example, something like this. 3t y1 prime minus 5 y2 prime plus, let's say, e to the power t y1 minus cosine t y2 equals t. And another one is y1 prime plus y2 prime minus e to the power minus t y1 plus sine t y2 equals cosine 3t. So how can I write this? It will be like this. I have 3t here minus 5, 1 and 1, and then I have y1 prime, y2 prime plus e to the power t minus cosine t minus e to the power minus t sine t y1 y2, and this is equal to t times cosine 3t. Okay, so this is a 2 by 2 system of first order linear differential equations. However, we will consider actually a more simple case. Well, not actually, it is equivalent to this one, but it looks simple. We will, however, ya da şöyle yazayım. For simplicity, we will consider the case where A is just identity. Okay, so this means what? I have equations of this type. Let's say y1 prime equals, and let me take all the other terms to the other side. Y1 prime is equal to, and here we will use again a notation for the you know instead of b I will write a, so we will have something like this: a1 1t y1 and up to a1 and t yn, and then I have b1t. I will have y2 prime, so a21t y1, a2nt yn plus b2t, and it will be like this, n1t y1 a-n-n-t y-n plus b and t. Okay, so we will consider equations of this type. In other words, we will assume that this function here, this matrix here is invertible, and I multiply this equation by A inverse, so I will have only y prime term here. Okay, and then A inverse times B equals A inverse times C, and then I take this term to the other side, leaving y prime alone on the left hand side. Okay, so we will consider this kind of equations, and I will write the coefficient matrix for y terms as A, not B. Okay, because I got rid of A anyway. And this can be written, of course, like this: y times A times y plus B, where A is y is again y1 t y and t, and okay, this is prime. Y prime is, for a matrix of functions, prime will mean that just the derivative of each entry. Okay, A is just Aij t, this is an n by n matrix, and B is just Bit, and this is a n by 1 matrix. Okay, okay. You may wonder, this is something very special, right? I mean, we just consider only first order equations, linear equations, and it looks something very special. Why not we consider more general situations? Here is the reason for that. Uh, uh, any system of linear differential equations, I mean ordinary of course equations, uh, is equivalent to a first order system. Therefore, studying first order systems is not actually restrictive. You actually consider all linear systems of any order. Why is that? Well, let me explain this on an example. For example, consider the following system: a 2 by 2 system. Let's say y double prime plus t times y2 prime minus 3y1 plus 5y2 equals cosine t, and I have, let's say, y1 prime plus minus e to the power t y2 prime plus y1 minus y2 equals sine t. So this is a 2 by 2 system. 2 by 2 system. I will convert this to a first order system of equations, but this time I will have 4 unknown functions. Here unknown functions are y1t and y2t the unknown functions, right? This is a second order linear system with two equations, right? Two equations. Okay. This is equivalent. This system is equivalent to the following first order system of four equations. Well, let's see how we write down that system. Well, what we will do, we will consider the derivatives of y's as different functions. So, for example, let me just write down. Y1 is just, sorry, U1 is just Y1, okay? And U2 is just Y1 prime. U3 is Y2 and U4 is Y2 prime. So instead of Y1 and Y2, I have now four functions, U1, U2, U3, U4. So we have we will have four unknown functions, okay? But this time all the derivatives will be at most first order. Why is that? I have y1 prime here. What is y1 prime? Let me write here. U1 prime is just y1 prime, right? Y1 prime. And y1 prime is what? Let me write here. Y1 prime is just U1 prime is Y1 prime, and U1 prime is equal to U2. So from this we get this equation. U1 prime is U2, okay? And U2 prime is what? U2 prime is just Y1 double prime. And what is Y1 double prime? Y1 double prime can be written from this as, okay. Yani şimdi tabii buradan görüp yazamıyorum ama isterseniz şöyle yapayım. Şunlara okey. T çarpı y2 prime T çarpı y2 prime u4 oldu. Değil mi? y2 prime u4 plus 3y1 3y1 plus 3u1 and then nedir? Bir de eksi 5y2 y2 de u3. Dolayısıyla u2 prime u2 prime bir dakika u2 prime evet y1 double prime'a eşit y1 double prime buna eşit artı bir de ne var? Cosine t var. Plus cosine t. What about u3 prime? u3 prime u3 prime is just y2 prime and y2 prime is just u4. So u3 prime is equal to u4. What about u4 prime? Well, this is y2 double prime. And what is y2 double prime? y2 double prime is equal to, oops, y2 double prime is equal to e üzeri t y2 yok. Y2 şey yok. Y2 double prime yok zaten. Bu equation'dan şunu da şöyle yapayım da okey. Şöyle olsun. Y2 double prime daha doğrusu U2 no, U4 prime Y2 double prime eşit Y2 double prime'da e üzeri eksi t çarpı y1 double prime e üzeri eksi t çarpı y1 double prime y1 double prime nedir? Y1 double prime U2 prime eşit. Bir dakika ya. Yarısını görüp yarısını görmeyince şöyle olsun. Ya da daha kolay bir şey seçeyim de bunu yapmak zor oluyor. Göremediğim için. Şöyle diyeyim. Özür dilerim. Bir tane denklem alayım. Ya mesela sadece şöyle olsaydı okey. Okay. Y1 double prime minus t times e to the y2 y1 prime plus y2 equals cosine t. Burada da şöyle olsaydı y2 double prime plus e to the power t ya da bir tane denklem alayım. Şöyle. Tamam. Sadece y diyeyim. Şimdi bakın bu ikinci dereceden bir denklem. This is a second order linear differential equation, but this is equivalent to a first order system. How? Okay, this is the above equation is equivalent to a first order system. How? Well, let u to be y, u1 to be y, u2 to be y prime. Then we have what? We have the following equations. U1 prime is equal to y prime, and y prime is equal to u2. So from this we get u1 prime is just u2. And what is u2 prime? u2 prime is just y double prime, and y double prime is equal to what? Y double prime is just okay, y double prime is equal to e to the power t times y prime minus y plus cosine t, and that is equal to what? So y2 prime is equal to e to the power t times y prime. Y prime is just u2. So e to the power t times u2 minus y, which is u1 plus cosine t. So we have the following system then. u1 prime is equal to u2 and u2 prime is minus u1 plus e to the power t u2 plus cosine t. If I write in matrix form, this will be what? This will be something like this. u1, u2 derivative. Uh, this is just 0 times u1 plus 1 times u1, u2. So it is like this. u1, u2 plus I have no, non-derivative term, but here we have cosine t. So it is equivalent to this system. And you see here only I have first order derivatives. This second order equation is equivalent to this first order system. If you have two equations and more, you can just do the same for all the equations and you get again a system. Okay. Here uh, instead of derivatives, higher order derivatives, we have only first order derivatives, but there is a cost for that. And what is that cost? We have more variables. So we had a single equation here. This single equation became a 2 by 2 system. Okay. All right. Well, we have the following, general form. And we have the following existence uniqueness theorem. Please stop me if you have anything you don't understand. Okay, now consider the following first order linear differential first order system of linear differential equations. What is this? It is y prime is equal to ay plus, usually it is written like this, where y is this, y1t, ynt, a is just ait, aijt, this is an n by n matrix, and b is bit, this is a n by 1 matrix. Okay, so if I write this in open form, I will have, let's say, y1 yn here, and then a11, a1n, an1, ann here, and then y1 yn, and then plus b1 bn. Okay, this is the open form. The conclusion is the following. If these coefficient functions, what are they? A and B, functions of matrices, if they are continuous, okay, if AT and BT are continues on an interval, uh, let's say I, uh, uh, AB, or let me say alpha beta, then any initial value problem uh, of this type. So y prime equals ay plus b, and y t0 equals b0, or sorry, y0, where uh, t0 is just any real number here, and y0 is any vector. Okay, any vector. Let's say so y1 0, yn 0. Okay, any vector. This system initial value problem has a unique solution. Y equals, let's say, phi t defined on the interval alpha beta. Okay. For the proof, şöyle yazayım. We will find the solution of the system and that will prove the existence part. Yani çözümü bulacağız zaten. O da çözümün varlığını kanıtlayacak. Uniqueness partı ise for the uniqueness one has to go through the proof we mentioned. Proof for first order ordinary differential equations considered earlier. Considered before. Yani uniqueness parti içinse daha önce sizde bahsettiğim o existence uniqueness teoremine gitmek lazım. Orada ordinary differential equation'lar için yapılmıştı o ispat. Ama aslında bunun için de geçerli. Orada sadece yani şöyle bir şey yapmıştık orada. Y prime f of xy değil mi? İşte y let's say x0 equals y0. Bunun existence uniqueness'ını yapmıştık. Burada daha kolay olacak. İşte y prime eşittir ay plus b. Burada da y t0 equals y0. Yani şu fonksiyon daha kolay ama bu sefer bunlar matrisler. Bunlar hani real valued fonksiyonlardı. Bunlar matris valued fonksiyonlar. Ama ispat aynı ispat. Sadece sayılar yerine vektörlerle çalışıyorsunuz. Dolayısıyla ispatın özünde bir değişiklik yok. Yani one variable real valued function yerine vektör valued fonksiyonlarla çalışıyorsunuz. Ama ispat aynı ispat. E, Zaten şeyi de existence partını da biz yapacağız. Yani çözümü bularak işte çözüm bu diyeceğiz. Uniqueness içinse teoreme dönmek gerekiyor. Yani orada yapılan ispatın tekrar bu şey için yapılması lazım. Vektör valued fonksiyonlar için. Okay. Şöyle diyeyim. One has to modify that proof for vector valued uh, equations. Or maybe vector for equations of vector valued functions. Okay, this way is better. Peki, existence kısmını yapacağız dedik. Nasıl yapacağız? Şimdi buradan sonrası aslında bayağı bir lineer cebir. Şimdi biz şeye bakalım. Nasıl nesnelerle uğraşacağız? Şöyle diyeyim. Şimdi bu 7.1'di. 7.2 ve 7.3'te şeyler var. Matrislerle ilgili şeyler. Belki onları az çok söylemekte fayda var. Şöyle diyeyim. Section 7.2 and 7.3 burada review of matrices and eigenvalues and eigenvectors. Okay. Bunu gerçi çözümün içinde yapacağım. İlk önce şu matrislerden konuşalım. Elimde bir tane matris varsa, bu fonksiyonsa, yani işte şöyle A11T, A1N T, kare matris olmak zorunda değil. AM1T, AMNT. So this is an M by N matrix. Matrix of functions. As I actually mentioned above, the derivative of AT is denoted by A prime T is şöyle diyeyim, is defined as şöyle A prime T, bu da nedir? Her bir entry'nin türevini alıyorsunuz. Başka bir şey değil. A M1 prime T, A Mn prime T. Okay. So derivative has the same size. Burada tabii ki şey nedir? E, özellikler, properties. E, A ve B'nin iki matrisin toplamının türevi. Hatta şöyle diyeyim. Lambda A plus ya da C1 A plus C2 B'nin türevi nedir? C1 ile C2 eğer sabitlerse bunları işte çarpıp toplayıp türevini alırsanız her bir entry'de aynı şeyi yapıyorsunuz. Dolayısıyla bu C1 çarpı A prime plus C2 çarpı B prime olacak. Where C1 and C2 are just real numbers. Actually, we can also consider complex values, doesn't matter. And we will actually do that. So let me write it in this generality. What about products? What is the, if you have two matrices which can be multiplied, then the derivative of the product will be just A prime B plus A B prime. Why is that? Well, this is simple. If let's say Cij is just A times B matrix, then what is the Cij term? This is just a summation of Aik times Bkj, right? K from 1 up to n. So Cij prime then will be what? Derivative of this term. So Aik Bk, sorry, J prime summation over K. Well, you just take derivative of each term, but you know these are just products of two real valued functions. And what is that product? What is that derivative? It is just Aik prime Bkj t plus Aik t Bkj prime t, right? It can be written like this. And this is just what? K Aij, sorry, Aikt Bkj t plus another product Aikt Bkj prime t. And what is this? Well, this is just the product of the matrix A prime and B and its kj term. And what is this? This is just A times this time B prime, and again, no, not kj, ij term, and this is again ij term. So uh, uh, what was C? C was A times B ij term of this derivative, right? Cij is just ij term of A times B, so its derivative is just A prime B ij plus A B prime ij. Well, this means A times B derivative is just A derivative times B plus A times derivative of B. Okay. Let's, for example, consider derivative of inverse, you know, just an example. If A is an invertible sorry, invertible uh, matrix uh, with whose and if a derivative of a exists, then we have what? A times A inverse is equal to identity, right? And thus, taking derivatives, we get. So when you take derivative, you get derivative of A times A inverse plus A times derivative of A inverse equals derivative of identity. But this is a constant matrix. Its derivative is just the derivative of its elements. They are either 0 or 1 constant functions. Therefore, the derivative is just 0. So from this we get what? We get uh, A times A inverse derivative is equal to minus A prime times A inverse, and therefore the derivative of A inverse will be what? I have to multiply this by A inverse, so it is minus A inverse times A times no, A prime times A inverse. So it is not just 1 over y prime squared. Şey nedir? Bir fonksiyonun tersinin türevi yani şuna eşit değil. Demek istediğim o. Bu eksi 1 bölü a kare y prime a prime değil. Çünkü matrislerin çarpımı değil mi? Komutatif değil. Bu a prime'ı buraya aktaramayabilirsiniz. So it is this one. Okay. All right. Let's give a break. After the break, we will see how we can actually solve the systems. Okay, we will consider several different kinds of systems, and we will of course make use of linear algebra. Okay, let's give a break now.